Good morning students, myself Dr. Shantini Bhattacharya, Assistant Professor of EC Department, SRM Institute of Science and Technology, Katankulatu, Chennai. Today I am going to start a new topic, JK flip-flop and T flip-flop. So these are the contents, JK flip-flop first and then I will describe T flip-flop. So what is JK flip-flop? JK flip-flop is actually in the case of SI flip-flop, we have seen that when we apply J and K both 1 and 1, then the output is actually the invalid state. So there is no valid output. So to overcome this problem, JK flip-flop is introduced. So here this is the block diagram where J and K is the input, clock is the another input, and Q bar is the output. Okay. So here when we apply J and K both 1 and 1, so it will not the invalid state. So what will be the state we will actually show in the operation. So this is the circuit diagram. Here basically 4 NAND gates are used, and here also I'll tell the same thing, that basic principle is the NAND gate principle. Based on the NAND gate principle, here also JK flip-flop works. Okay. So if I consider this one is NAND gate 1, this is 2, 3 and 4, then NAND gate 1 is connected, one input is J, another input is clock, and third input, this input is connected to Q bar, complement of Q. And this is NAND gate number 2, one input is connected to K, another is clock, and another is connected to Q. Now what will be the operation? So now I am actually starting the operation part. So here actually this is the clock, J, K, Q and Q bar. These are the 4 conditions. If clock is 0, then whatever be the J and K condition, then Q and Q bar will be no output. Okay. Then this is 0 0, 4 combinations there will be. So 0 0 0 1 1 0 1 1. Okay, this 4 condition. So all in 4 condition, clock is 1. So now we will start with this condition that clock is 1 and J equals to 0, K equals to 1. So here J 0, K 1 and clock is 1, as there is a, and also I have denoted this is 1, this is 2, this is gate number 3, this is gate number 4. Okay. Now as there is a 0 is the input, so according to NAND gate principle, output of the gate 1 definitely 1. Okay. Then I will actually we will not see other input, because there is a one input is 0. So now in the gate number 2, 2 inputs are 1 1, so we have to check what will be this input. Okay. So here we will consider that Q previous condition was 0. Okay. So this 0 is connected here, so this 0 will come 1, 0 will come in this input, that means NAND gate of the second NAND gate input. Okay. So you can consider here 1 also. Okay. So both the condition, the output will be same. Okay. So as there is a 0, so definitely also output will be 1. Okay. So now this 0 again here it will come here. So this 0 1, that means again it will come 1, as there is a 0 it will come 1. Then 1 1 1 1 means 0. That means now the present state also Q equals to 0 and Q bar is equal to 1. That means this is 0 and this is 1. This is called reset. Okay. Now next we will take another combination. Okay. So here basically we will apply J is equal to 1 and K is equal to 0. So now just see what will happen. Okay. So what will happen? J equals to 1, clock equals to 1, K is equal to 0. Okay. So Now what will happen, as this is 0, that means it will definitely 1. And now there is a 1 1, okay, in the gate number 1, here both J and clock is 1, so we have to see what will be this input. So at that moment we consider this is 0, you can consider 1 also, okay. So this is 0, that means definitely it will come 1, okay. So this actually 0, this 0 will go here. 0 1 means, as there is a 0, definitely output will be 1, and this 1 comes here, so 1 1 means output will be 0. So this is 1 0, that means set condition, okay. Now we will start, that means J and K both are 0 0, okay. Now we will start that both are 0 0, okay. Clock is 1, so what will happen here, here both are 0 0 condition, so as 0 0 is there, both J and K 0 0. 0 0 means definitely output will be 1 1, okay. So now if we get that moment, just consider there is a previously there is a input is 0, that means Q bar equals to 0. This 0 is goes here, 0 1 means it is 1, okay, and this 1 will come here, 1 1 means 0. That means previously we have just think that Q bar will be 0, and here also Q equals to 1, but after applying this value, again it will come Q bar equals to 0 and Q equals to 1. That means this is the same previous state, that means it is called hold state or no change, or you can say no change, okay, no change of the previous input, okay. Now we will give last combination where both J and K will be 1 and 1. So just see what will happen. Here also 1, here also 1, okay. So here J is 1, clock also 1. So if we consider Q bar is 0, okay, so Q bar is, you can consider 1 also. I am telling continuously that you can consider 1 also, same result will come, okay. So here I have just considered here 0, that means 0 is here, 0 is here means here it will come 1, okay. So here that means here also is, it is, as it is 1, it is, here is actually it is 1, okay. So this actually this 1 will come here, 1 1 1 means it is 0, okay. So then 1 and this 1 will come here, 1 0 means it will come 1, and this 1 will go here, 1 1 means 0, okay. So that means previously it was 1 0, now it will come 0 1, okay. So that means it is called toggle, okay. This is called toggle. That means previously we considered that Q bar equals to 0 and Q equals to 1, but after applying this we have seen that Q equals to 0 and Q bar equals to 1. So this is called that whatever the previous output, just or after applying this previous output we will get just opposite of the previous output. This condition is called toggle condition, okay. This is actually the advancement of the, actually we can say this is the advancement of the JK flip-flop from the SR flip-flop, okay. So here I have written all the steps here, that means this is E for actually the enable or clock input. All 4 condition, clock is 1, 0 0 means no change, 0 1 means reset, 1 0 means 1 0, that means Q equals to 1, Q is equal to 0, this is set, and 1 1 means this is called toggle condition, okay. So now we will go to the next step. This is called toggle flip-flop or T flip-flop. Okay, so T stands for here toggle. So this toggle flip-flop is actually a JK flip-flop, but difference is these block term. If you block diagram see properly, you can see that these J and K input are connected together. Okay, so here there is only a single input. This is called input T, and also clock is definitely there, because without clock flip-flop will not work. So here only single input T and output Q and Q bar. Okay, so just now I'll show you how actually it will work. Okay, so what is the condition? That here is actually the here you can see this is the input T and this is J and K, and here output Q and Q bar, same actually the figure of the JK flip-flop, but problem is here J and K are shorted. Okay, so what will happen if I'll give here the 0, then both J and K will be 0 0. Then according to the JK flip-flop principle, in 0 0 condition, that means output will be no change. Okay, so if you just see the previous state, that J and K 0 0, that means it is no change. Whatever the previous output, the same output will come next also. So this is actually the same case will happen here. If T is a single input, J and K both are connected. So if I'll give here 0, then both J and K will be 0 0. So if J and K 0 0, output will be no change. So here it is showing the same case, that T equals to 0. Q previous state, previously it was 0 and 1. Then next also what will happen? 0 and 1, that means no change. Okay, and same again 0 we will give T as a T input. Then now previous state is 1 and 0. Then what will be the output after applying T? Then same thing, that means Q equals to 1, Q bar is equal to 0, because previously it was 1 and 0. Same actually output will come, because it is a no change condition. Okay, now if I will give T equals to 1, T equals to 1 means J and K both are 1. In the case of, just if you see the JK flip-flop truth table, if J and K both are 1 1, it will be a toggle. Toggle means the opposite previous output. Okay, opposite output of the previous. Okay, so if there is actually T is 1, previously Q equals to 1, Q bar is equal to Q equals to 0, Q bar is equal to 1. Then what will be the next? Q will be just opposite, that means 1, and Q bar is equal to 0. Okay, so this is just opposite. Same thing, T equals to 1, previously it was 1 and 0. Now what will be the next output? Q will be 0 and Q bar will be 1. So this is actually the main principle of the T flip-flop. Okay, now this is the operation, same thing, whatever I have said, same thing already I have written as a truth table. That means if clock is 1 in all the case, if T is 0, it will be no change. If T is 1, it is a toggle condition. Okay, so these are basically the applications of flip-flop, like counter, frequency divider, shift register, storage, all are the application. In the next video I will start the register and also counter one by one I will complete. So keep watching my all video, then it will be helpful for all of you. Thank you so much, and if you have any doubt, then give me this doubt in the comment section. I'll try to solve all these problems. Thank you so much. Keep watching.